All right, good afternoon. And then we just had an exam last week. If you have any questions, today I won't be able to do any office hours. So we can try to talk about it on Thursday, about the exam, okay? And also next week, I have to go somewhere and then we're not gonna, I think I'm gonna hold any session next week. But if I don't, I might send you some stuff to work on by yourself. Just for next week because I have to do a couple stuff next week. I want that specific Zoom time. I have to go somewhere else. Exactly. So I will send the other one a note about that. But if today there is no, I won't be able to do any office hour today again, but I'll do it after class. I mean on Thursday after class. Okay. Does anybody have any question for me? Where is my tax thing? Can you guys hear me very well? Okay, so I'm going to be sharing my screen. We're going to continue with what was started earlier. I will share my PowerShell slide. See right here. Okay. What we're going to be talking about today is something called modeling linear trends, or you can say linear model. Okay. This is what happened in this case. In this case, we're going to be talking about a line. Okay, so what we used to do in the past, and if you remember from 1033, because 1033 is one of your basic requirements for this class, we used to have something called a slope forming the equation of a line. And if you remember that equation of a line, and that equation for line used to be something like this: y is equal to mx plus b. Okay, so b is called the y-intercept. M is called the slope. This is from 1033. Okay, in which M is also equal to rise over run. This is from previous classes. Okay, so we're going to be using the same concept in this class, and then in this concept we're going to develop something called also a line as well. Okay, but for now we need to just remember that you have to put in the back of your mind, this is the equation of a line. Okay, it will come in different shape because this is statistics. I'm going to try to apply to real world situation. So to keep on mind on that, that is going to be something like this. Okay, so whenever what they're trying to tell you here, whenever you have a bunch of dots, a bunch of dots, and like you have the plots like this, that line here is this one you're going to call y is equal to mx plus b. In this case, this one is the height and the weight. So what I will do for the graph for that one, what I will say is for something like this. Hold on, let me just use my pencil, a different color. Use that. In this case, the graph will be something like this. Why is my pen? This one can be something like this. You can say this is weight. Let's put W for weight. Give me 1 moment. I'm going to get somebody in. Admit all. Where's my text thing? Chat is here. Okay. All right. Okay, then. So, and this I'm gonna say, I will, if I put W forward, I will say this one, this is W, this is H in inches. I can say W is equal to, okay, M, which is the slope, okay, which is the slope, and then times W, I'm sorry, times H, which is the X value, and then plus B, okay, which is the y-intercept, okay? Again, this is the, we can say this is the weight is equal to M times the width times the height plus B, all right? So this one, in that case, whenever you use it for Euler situation, we don't really say equation of a line anymore. We say this is called a least square regression line. That's the name for it. Least square regression line. So what is that? It's called, it is the best fit line for the data. Whenever you have a bunch of numbers, a bunch of data, you plot in let's like we did last time. The line that you guys always saw me draw, when I used to draw it, that said, oh, to know which sense and which orientation is the line, is the graph. That's what I'm talking about. This one, you call it the best estimate. You call it the best fit. Let me just show quickly when I did it before with you. In the past, I had to draw this line. See that line? That's what I'm talking about, this specific line. Okay, this one is called Y is equal to mx plus b. In this case, you can say W is equal to M times M, capital M for men, plus B, something like that. And so on. We were gonna find a way to find the slope, etc. in the future. Okay? Any question about that part so far? Get somebody in again. Okay. So this is called also the best line, the best fit line for the data. So this is the one probably that give you the idea or whether it's gonna be to the left or to the right, whether there's an increase or decrease, it give you an idea. But at the same time, the rise over one of the slope is this far right here as well. If you're looking at this one right here, if I'm looking at this point, this specific point, I'm gonna use a red color. Let's see, color red. Right here, if I'm looking at this specific point right here, this one has a rise and run. If I look at these 2 points, okay? So here, this is the run. The rise will be something like this. It's go up some unit, and then it's gonna go run. This is the rise, and this is the run. Okay? To this point. All right? In that case, what it means that in that case, the mean value will be on the regression line. Okay, and this is how I call this one. This is the best fit of the line. So this one say that's it's a work. You say the line minimize the average square vertical distances. So that's something you can just read on your own. Okay, this is only useful data for linear model. So right now, you guys gonna be working, we're gonna be using this specific expression for a linear model, okay? It has to be a straight line. That's why we talk about the equation of a line for a straight line, okay? It's gonna be a straight line. That's why it has to be a straight line. So remember that. And then the slope, again, is also rise over run. And then sometime in the past, I don't know if you remember that, it's usually something like this. You can say y2 minus y1 over x2 minus x1, if you remember something like this in the past. And that's why I call the slope, or we call the rise over run. Okay, in this case, if I would like to know the rise over run for this one, as you can see here, if I can like to know the slope, this one right here, I would say, for example, this is 62 comma, and then 110 for the X value, for the Y value. Okay, if I can remember you, the first value is always the X, the second value is always the Y. And then for this one right here, this is gonna be 63 for the X value, and then comma, and then that'll be 140 for the Y value. So if I would like to know the slope for that, what I'll do, M is equal to, the rise will be, say Y2 minus Y1, that'll be 140, take away 110, divided by 63, take away 62, because the 1 is only 1 unit. And that's going to give you M is equal to, now 140 take away 110, that's going to give you 30 over 1. It means that for every 30 pounds, there's an increase of 1 inches. Okay, because it's gonna be this is the slope. Is a pound per inches. You can say this is pound per inches. This is pound. Okay, give me 1 moment. I'm trying to get my cursor here. It's gonna be pound per inches. That's mean for every 30 pounds, okay, there's an increase of 1 inches. Okay, that's what I mean. I'm gonna talk about that later on again. So that's how you get this is something from 1033 stuff. So you can just remember how to get the line. Whenever you got a bunch of line, then that's how you get the slope, etc. Okay, so I'm just gonna skip this part. I'm not gonna use such crunch. You don't have to use such crunch, but this is what happened in the exam. I may give you these things right here for you to read. Okay, so here, as you can see here, maybe even though you didn't calculate it, but it's going to be given to you. Whenever they talk about independent variable, it's going to be the X value all the time. When they talk about dependent variable, it's going to be always the Y. You have to remember that. Dependent variable are always the Y value. The independent value are the X value. As you can see, this one's a monthly average ad and $100. This is the Y here. Is equal to, now here, because this is a program, they like to put the y-intercept first and then plus. Now, this one say it's gonna be 1.20 something revenue per day and 100, something like that. So here you can just say this is gonna be 1.22 to 5.8, something like that, time X. Okay, X, which is the revenue per day in 100 seconds, something like that. Okay, so there's something also called correlation. We talked about that number last time. This will give you the correlation. For example, the correlation for that data they're working about is about 0.9072. Okay, and then there's something else that is also very important that you need to understand, something called R square. This one is the correlation, you square it. And this is 0.9072. Then this is square. If you use a calculator, that should give you something called the R square. I'll explain to you later on what the R square stands for. Okay, so can somebody, just to double check, can somebody use a calculator and do 0.9072 times 9072, or you just square that? What does it give you? 0.9072 square, how much is that? Use a calculator just to verify. Thank you. That's going to give you 0.823. See that? So that's called, this is called R square. Okay. So what does R square stand for? I will explain again later on today, but I'm just going to give you a quick idea. It means that 82.3%, you need to put in percentage, are explained by the regression line. That's what it means. So 82.3%, so you can say about 83%, you can just round it, 82%. If you say 83%, that's mean about 17% are not explained by the regression line. That's mean whenever you have your stop, it doesn't have to be 100%. Even though the line represents the best fit line, it doesn't explain 100%, but it does explain 83%, about 83%, which is a really good value. 83% is a really good value. Okay. So this is more than average, because average is about 50%. But if you below average, that's a problem. But 83%, that's really good. Okay. So let me keep going. Does anybody have any questions so far? Okay. So you're gonna have things like that. You guys, you just have to find the expression. So when they say what is the y-intercept, or what is, well, that's mean when x is equal to 0, when there is no revenue, what is the monthly ad expense will be? You're gonna say is about, if there's no revenue, then therefore the last number will be 0. Okay, so let me just give you the next example. I always spoke to about what's the one in slope, so I'm going to talk about this one. This one here, this one's a price revenue. Okay, 1.8 is a plus 1.2 that time they add. Now we got 1.5 point something like that. Okay, so you said the slope in this case is 1.2. That's what you're going to be doing. You're going to say, what is the slope? Based on the data I just gave you, you can say the slope is about 1.2. Okay, now what does that mean? Again, whenever you have the slope m, if there's nothing below it, I mean, this is always rise over run. Remember that. Okay. That's mean if this one can give you 1.2, if that's nothing at the bottom, if it's not a fraction, you're just gonna put 1. That's mean it means that if x increased by 1 unit, y has an average increase of 1.2. Okay. You can also say for any average of one increase of 1.2, x increased by 1. You can also say the other way. Okay, if x increased by 1 unit, y has an average increase of 1.2. And then this is the best way to do it because x is supposed to be the independent variable. Okay, earlier I wanted the dependent variable first. This is independent variable, and the other one is a dependent variable. So we're gonna use that kind of concept next time. Okay, this one is independent, this one is dependent. So for any increase of about 1 unit, y has an average increase of 1.2. Okay. All right then. This one say for every $100 the company spent on ad, the average addition of 120 on revenue. What does it mean? Where did they get that 100 from? This is what they do. Suppose I say, if you spend $100 on ad, how much revenue will you do? So this what happened. You're gonna say again, y is equal to 1.8 plus 1.2 times the ad, right? I would call it x. If you want to, because this is a real life situation, we like to put the letters exactly the way they are. One is add, the other one is pay. But because I'm doing the math, I can just use x and y. Okay. So I will say y is equal to 1.8 plus 1.2 times 100, because they said $100, right? So so that's gonna be y is equal to 1.8 plus 120. Okay, so that's why they say the additional. Okay, if that's mean the basic thing, if there's no price, they will spend only 1.8. That's why they say additional $120. That's additional. Okay, but if you add both of them, that's gonna give you y is about a 121.8. You see, where's my pen? You see, 121.8. That'll be what number. That's the reason they say addition is because of the process. I mean, if they still have to spend every month 1.8, $1.08. They still have to do that. But if they spend $100 in ad, they have to send an additional 120. Now, if they don't spend anything at all, so what does happen? If they don't spend any dollars at all, that means if x equal to 0, I think that's the next example. I don't want to go over it. If the x equal to 0, then they're still gonna spend $100, $1.8 all the time. Okay, so any questions so far? Let me see. Any questions about that one? Okay, you guys don't have any questions. So this is what I was talking to you earlier here. Let me just go back here. This is also talk about y-intercept, I just talked to you about that earlier today. Here, for example, here, that's what I say. Suppose the company spend no money at all. Okay, they spend no money at all on an advertisement. It is predicted to have an average daily revenue of $180. Okay, so this one is assumed to be let me see. There was a mistake with the symbols. It's per $100. So I added a mistake right here. So let me see. Let me go back here again. Okay, this one is not really 1.8 because this is per $100. That's mean everything here you have to multiply by 100 at the end. Okay, it's only 1.8. So that's mean if I got this number, you got this number because it's a per 100. Okay, so I'm gonna have to multiply by 100. That's mean the real amount of money they spend is gonna be something like this: 121. Okay, and then 80. So that's be about $12,000. That's what I mean, because it's per 100. All right. This is how much you're gonna spend because they say the weight was per 100. I don't know if you guys remember that. We talked about it earlier. Let me just show you quickly. Right here, where's it? Where's the slide? Right here, it did say that it's revenue per day and 100s. Okay, it has to be on 100. So this little detail you have to pay attention to them whenever you do this kind of work. Okay, so that's they're gonna spend like something like it. So if they don't spend any money on advertisement, they still expect to spend about $180 anyway. Okay, because they're gonna do a 180 because ad will be $0. Okay, that'll be 0. That'll be just 1.8. Okay, then time 100. That's gonna give you 180. Okay, give me one moment. Okay, so let's keep working. Let's see. So this, I'm gonna let you read this little thing, why not to use or when not to use it, stuff like that. Okay. This is gonna lead the way. I'm gonna put the note for after class. We already spoke about that before. That whenever you have correlation, it doesn't mean that there's a cause and effect. So I already spoke about that before, so I'm gonna skip this one. Okay. This is a general idea of what it means. Whenever we're talking about the regression line, if you have a bunch of data, but that line, whenever you draw it, you give you an idea where the line is going. As you can see here, this is an increasing line. Okay, going from left to right, you increase from left to right. Okay, because the line looks similar, I can say there's a correlation probably. I can say by 0.90 if you want to. 0.90. It doesn't have to be perfect right now because I didn't teach you how to calculate the regression line. I mean the correlation, but right now we're just gonna based on just estimation. Okay. So that's what I've been doing before. Whenever you should see that bunch of number, it gives you where the line is going. So as you can see, this is positive, and this is there's correlation here. Okay. We're not gonna do any correlation if it's not linear. So we're gonna that's why I say we're not gonna be doing that if it's not linear. So don't worry about that part. Okay. And I just spoke to you earlier that the slope, there's no relation between slope. I mean, I'm sorry, between correlation and cause and effect thing. So let me skip this one for now. I'll come back to this one after that. Let me just go all the way there. Give me one moment. Let me just go all the way there. This one. I was talking to you about the R square. Okay. So suppose you have R is equal to 0.90. Okay. This is what we call the correlation. Okay. If this, in that case, as you can see, this is a positive correlation and it is strong because it's 0.90. It is a strong correlation. It's strong and it is increasing. Okay. It's increasing. Okay. Increasing. So the R square here is something else. A R square is always equal to, suppose the R is 0.90, that means it's going to be 0.90 square. Okay, which is going to give you, I think it's going to give you 0.1. If you do 0.90 square, how much you guys think it's going to give you? It's going to give you 0.81, right? How much is going to give you? Perfect. Yeah, 0.81. Okay, so here, this one say R square measure how much of the variation of the response response variable y can be explained by the explanatory variable. Okay, so this is a bunch of language. Or I can say R square can also explain the percentage that is explained by the regression line. That's another term to use as well. Okay, so also you say is how the term we use for them is used to help determine which explanatory variable will be the best for making prediction about a response variable. Okay, so if ask this one 81%, usually put them in percentage. Whenever we do the interpretation, we use percentage. All right. So an example here, this is definition that's for you to learn. An example here. Here, for example, they have R squared is equal to 60.5%. Okay, that's mean it means that 60.5% of the variation in the value of cars can be explained by the age of the car. So here we have the age of the car and the value and the dollar of the car. As you can see, this one has if you're looking at this one is decreasing, right? It's not negative, it's not positive. That's mean assuming that R, if I do the square root of 60.5, how much it will give me? Anybody do the square root of 60.5? Because to go the other way I want. Can somebody give me the square root of 60 point, I'm sorry. So R squared also can be expressed as 0.605. Can somebody give me the square root of 0.605? How much it give you? The square root of 0.605. That's means this is going to be negative 0.3, let's put 0.367, something like that. So here we have the correlation as negative. The reason I put negative is because the way the line is going through. As you can see, that the line going to the negative side. That means R must be negative. Okay. So that's something also you have to pay attention whenever you're doing the exam or the quiz. See the way that it's going to the negative. If I give you R squared and ask you to find R, so what you do, if R squared, you just can see this is R, you square it, okay? It means that R, that'll be the square root of R squared, okay? But in our case, the R will be negative. This is logic because I know that based on the graph I'm looking at right now, the graph goes the other way around. Okay, do not confuse. See, as you can see, do not confuse this part here with that number here. So as you can see, this one say 60.5% are explained by this line, but there are about 40% that cannot be explained. So this correlation, as you can see, is a little bit weak. As you can see, it gives you negative 0.367, which is a weak, not that strong correlation. That means the regression line doesn't explain too much. Okay. Any questions so far? Now, I have an example I would like to go over quickly. Let me just go. See. Let me see, give me a moment. This one. Here, in the exam, I might give you something like this. They give you the data. Here we have city as New York, Chicago, the cost, and the miles. Okay, the round trip. To do a round trip for 260 miles in New York is gonna cost you about $170, something like that. Okay, so this is how the question. This one say how much will it cost to fly 500 miles? Okay, that will be the question. And also, they said to use a complete regression analysis. So this is what we're gonna be doing. What they do, they're gonna do what you're gonna be doing, you're gonna have to do a line like this. You're gonna do something like this. Okay, that will be here, probably that will be the cost, the miles. This will M for miles. And here, that will be the cost. Something like that. It doesn't have to be perfect, but I don't think you're gonna be able to do it anyway. So as you can see, my cost go from $0. You don't even do zero, that's going from 0. And the highest one I have is about 397, right? No, 443. So I can say this one's going to send out 445, something like that. Okay. Then what I'm going to be doing is to draw them. Here we have this is going to be the Y values. This is going to be the X values because I put the miles. Okay. So for 206, you got 179. Suppose this is 206 right here. This is about half. That's mean 244, 206. 206, suppose this is 206 right here. Then 179, this is about 3,000. 179 will be somewhere around here, something like that. I don't know if you guys got there. This is 179. Okay, 179. And the dots will be right here. Then you're gonna do everything for the other ones. You're gonna put them like this, the same way you find it. Okay, something like this. Okay. Now at the end, this is what we do. Which is why we have something like this. Okay. So as you can see, the Mars. Did I mess up the numbers? This is Mars. Mars, yeah, yeah. So why did I put 400? This is 206. This is 3. I'm supposed to put 3,000 here. 3,000 something here. Because I got some. This is 3,000, and then this one should be 443. My mistake. 400 and let's put 445, something like that. Okay. And then you do the graph. I did say this one is mild, did not mistake any change them. This is X again, and it is Y. This is one is the X value. This is the Y value. Okay. So at the end, you're gonna have something like this. Like this. Okay. That's the graph that you have. Okay. You can see that if I try to do a line, a regression line, which I can do using Excel, stat data, something like that, it look like there's something. The tendency is like this, something like that. Okay. Then this is what you call the regression line. Okay, which I'm going to show it to you again right here. I'll do the math for you. I got everything. So this one says you tend to increase as much increase. There is no apparent strong correlation. The line is not appropriate. Okay, so here this is what we have. So using a scientific calculator, we're able to get the cost. Again, the cost here is dependent. The dependent variable is the cost. That's dependent. That's independent variable. Okay, you want to know how much you will pay each time you go over. I mean, you go some amount of miles. Notice carefully that I have R. My R is 0.70. I mean, that's mean there's a correlation. It's not very strong, but that's a good correlation. You understand? This is good. But how many of them you explain by the data, by the regression line, is about 58.6% explained by the data. So that's mean a little bit more than a half explained by the data. Okay. So that's a little bit thing we want to know. But remember, the question is how much it will cost you to fly 500 miles. That was the question. So this is what we're going to be doing. So before you do that, let's explain what it means first. Before I do the answer for that question. So let's talk about it. The slope here is 0.08, about 0.08. So remember what I told you, that whenever they don't put any number at the bottom, remember the slope M is always rise over run. Okay. So now they give you one number only, which is about, if you round it, they give you 0.08. Okay, over 1. That means for any increase of 1 mile, there will be a cost of 8 cents, something like that. Okay, that's what I can say. For any increase of 1 mile, there'll be a cost of 8 cents. You see, for any additional mile, on average, the price go up by 8 cents or 0.08, something like that. Okay, dollars. That's what it means. So what does the intercept stand for? The y-intercept is going about 163. That's mean if you don't drive anything, I mean, if you don't go anywhere, but you should expect to pay on about $160 anyway. This is what it means. So if you have 0 mile flight, that means I mean, it doesn't make any sense if you don't fly at all. That's what it means. But if you don't, I mean, you should have to pay $160. So that's why sometimes it's good to use the regression, the y-intercepts are not good to use it. But the example we're gonna be using gonna be straightforward. Okay, it doesn't need to worry too much about them. Okay, is this meaning that because if I'm not traveling, why will I pay 163? Again, statistic is not an exact science. Okay, it's not completely exact. There's gonna be you have to leave room for error. Okay, even though this might be the best estimate for this data, that means if you don't travel at all, you're gonna pay 163. This is the reason why it's like that. It's because of your R square. It's only 58% is explained by that specific line. That means this is kind of close to average, close to the middle. If it was a good predictor, that means it was 90%, then you will have that kind of error. I know if you guys follow what I'm talking about. If it was like 90% or 83%, I mean 80% explained, that big error wouldn't be here. That's one of the error that we're talking about. Okay, it's because only 58% you can explain by the data. Okay, so think about it. Any questions so far? Any questions? Okay, so nobody saying anything, so I assume that you guys understand. Now, the next concept. Let's find the 500 miles thing. We say that for 500 miles, what do we have? This is what you do. Again, this is the formula that we have. The predicted cost is equal to 162.6 times 0.7, something like that. So again, let me remind you I mean, it's right here. Right here, this is about 162.50 now, or 163 plus 0.08 miles. Okay, time miles. Okay, this is a time right here. This is what we have here. So what you need to do is just plug in 500 right here. For miles, you put 500 inside here, times that diameter by 0.0796, and then plus that extra value. Okay, that means if you do 500 miles, you might expect to pay $202.40. Okay, that's what it means. You might expect to pay $202, something like that. Okay. Any questions so far? Any questions? No questions. So let me go back to one of the things I wanted to talk earlier about. That's one of the examples I wanted to talk to you. So let me just go all the way to the top. What was it again? This one was the last week. So let's go all the way here. Okay. Here, this is also the same concept, which is y is equal to b plus mx. In this case, x is the equality in years. Okay. This is doing the interpretation. This one say each year, each year in college, each year in college result in additional salary increase of $8,000. So I know that with the slope here means 8,000 over 1. Okay, we say each year in college with an additional salary and increase of $8. So here we don't want to do that because it seems that there's a causation. Okay, so also here, wrong. So you cannot say a person with 1 more year of college education will earn an extra $8,000. You cannot say this kind of concept. The way you should say it, you should say on average. This is the keyword here. You have to say on average. People with one more year of college education tend to earn an extra $8,000. This is a way to interpret this example. That's the one I was showing to earlier. Okay, so this is kind of try to talk about the definition of the R. Okay, I can say also, some people can say also for any increase of 1, the other one increased by 8, there's an increase of 8,000. That's another way to do it. But for day-to-day life, you want to say something like this. On average, people with one more year of college education tend to earn an extra $8,000. Okay, that's another way to do the interpretation. So keep this in mind also. And also, we cannot forget about outliers. One day here, they tend to mess up the data. Sometimes it's something that you put inside of it. Okay, it does affect your data. They're also called influencer point. If they here, they will mess up your data a lot. Okay, so pay attention to the outliers. In this one here, as you can see, in this example, everybody is all the way there, and there's an outlier right here. So in that case, what it does create a straight line. It does create a straight line that go from here to there. So you make you think that it is positive. But in fact, if you remove it, this is what you have. You have the picture B. Whenever you remove the outlier, if you remove it, that's something like this right here. Okay, as you can see, first of all, whenever it was there, you make the R become positive because it was way way over there. But if you remove it, then the R become negative in this case. As you can see, this is called an influencer point. So be aware of outliers. Sometimes you're gonna have to remove the outliers. Okay, without the outliers, we got example number B. Okay. So, oopsie, where was I? So that thing you can just read on your own aggregate data. You just have to use the word mean. Okay, so think about the word mean. That's all you have to remember. So here, in this case, see they're not using the mean value. Okay, but there they use the mean values. Okay, that's why this one mean. If you're using mean, it's like whenever a bunch of data, sometimes people just can use the average value. If you're using the average value only, they call aggregate data. If you're not using any mean value, they are called just a regular value. Okay, as you can see, sometimes just using the aggregate value can increase the R. See that? Here we have a good correlation. Here on the first one, the correlation is weak. Right here. And this one is strong. Okay. So that's what you have to remember. So in the future, say if it is aggregate value, then you have to use mean. Okay. So you see, there's a weak correlation between math stat scores and critical reading stat scores. One is the math stat score, the other is critical reading stat score. There's a weak correlation. But if you use the average values, it has a strong correlation. Okay, so that's mean between state means math SAT scores and state means critical reading score. You just have to make sure that you use the term mean or average. Okay. One last concept I would like to explain to you right here. I just talked about this one some earlier, that sometimes you're gonna have to use that. So I'm gonna let you know for you to expect to read. So this is what happened. I'm gonna finish a little bit early today. Remember, next week I won't be here because I have to do something at this specific time. So I will send you some work to do. Right after class today, I'm gonna upload this note for you. Okay, I'm not able to do office hours today. If you have any specific questions, I'll be able to do any office hours for you next on Thursday. All right. Okay. Okay. Yes or no? Okay. So I'm gonna end up the class now. If you have question, I still have like 8 minutes left. Let me see. About 8 minutes left. And then on Thursday, I'll do after office hours on Thursday with you guys. So I do have 8 minutes left. If you have any question, please ask me right now. And just stop the recording. Where is that thing go?